came up the stairs. Okay, 5.2. LCMs, that's least common multiples, least common denominators, adding and subtracting. Because you gotta have a common denominator, add or subtract fractions, right? All right. LCM, 15 and 30, 40, sorry, yes. High five. There are 5 in common, but we're not simplifying, right? Right. So, but it has a 5. 5 times 3, right? Find factorization. 40 divided by 2 is 20, divided by 2 is 10, divided by 2 is 5.
8
so we got,
5.
Yeah, but we don't say 8, we do the whole, bless you, the whole prime factorization. And then to do an LCM, we do the most. See, and most. Remember, they will both go into, not that will go into them. So, the most 2's is 3. 1, 2, 3. The most 3's, we have 1 and none, so 1 is bigger than none. 1 and 1 is 1 bigger than, which one's bigger, 1 or 1? 1. Which one? Don't matter, top or bottom one, either one. Okay, so we got 10 times 12, 120, right? So those should both go into 120. 15 will go 8 times. This will go 3 times. So you could look at it right there. See? There's 40 times 3. Here's 15 times 8. Okay, it goes into it. It's in there, just like Prego. Okay. 8 was what? 2 times 2 times 2, wasn't it? 15 was 3 times 5. 5 is just 5. Most. 3 of those. 1, 3. Oh, it's the same thing. It's a 120 again. Different numbers, but the LCM's the same. Okay, this one should be different. They won't go to 120. 27 is 3 times 9, but we don't put 9. We put 3 times 3 times 3. What's 35? 5 times 7, right? 7 times 9. 9 is 3 times 3. Most. 3 and 2, so 3 is the most. 1, 5. 1, 7, 1, 7. Just 1. I don't see an easy way. We got 35 times 27. Somebody do it for me.
945.
945. They should all divide evenly into 945. Add by finding the least common denominator first. Least common denominator is the least common multiple of the denominators. So you find the least common denominator of, we're not dividing them by something, we're getting a common denominator. When you see this, go ahead and write it like this. What's the common denominator?
30.
30, yes. So 15 times what is 30?
2.
2. So this one's 8. 6 times what? 5 is 25. Write that plus from here over here. So you don't miss it.
33 over 30.
30, 25 and 8 is 33. And you can leave it improper. Okay? The book writes a lot of stuff improper. Huh?
You have to simplify it.
Oh, yes, you could divide by 3, yes. Sorry, you can leave it improper, but leave it improper simplified. What can we divide by?
11.
By 3, right? Divide by 3, divide by 3. Sorry, yes, simplify it. Good job, you caught it. Okay. This one, write them vertical. 5/12 plus 13 over 18. 18 and 12, if you don't know off the top of your head, what's 18 times 2? Huh? 18 times 2, 36. They'll both go to 36, right?
Yes.
So it must be 36. So 18 times 2, 13 times 2 is 26. 12 times what?
3.
This is just a review of how to do fractions. 15 times 3 is 15. So we have 36 plus 41's prime, isn't it? So we can't divide it by anything. So we're definitely done. Okay. Now we're going to get least common multiples with letters. Okay. This you can look at as 3 times 7, and there's a 7. Okay. The most, a 3 and a 7. The most x's, 2. Most y's, 1. Do what?
Don't you put X and then X?
You could. Yeah, you could spread it out. You could put XX, or you could just say what's the biggest exponent. So this is 21, x squared y. That's the least common multiple. Okay, so 15 is 3 times 5, ab squared. This is just 3.
3, AB,
And 10 is
2 and 5,
2 times 5. Okay. The most, a 2, a 3, 1 and 1 is just 1, and a 5, 1 and 1 is just 1. The most A's, 3. The most B's, 2. Right. This is 30. There's your least common multiple. Okay, this has to be factored. The prime factorization would be actually factoring it. What do you factor? Factor out of 5, right? 5 times y plus 3. This will be 2 factors. Y, it adds up to 6. 3 and 3, right? 9 is 3 and 3, that adds up to 6. Signs?
both of them are going to be negative.
Negative, negative, has to add up to -6. So our least common denominator, our least common multiple would have the most of everything. There's a 5, there's 1 of these, and there's 2 of these. So you put both of them. You write it twice, but it's easier just to write the squared. So least common multiple would end up being a common denominator. If these things were on the bottom, that's how you come up with the common denominator. Using the least common multiple of the denominators. One more least common multiple. Factor this. What can we factor? Can you see it? Doesn't look very focused. Factor out. What can we factor out?
X to the third.
Third. Okay, so we have x squared plus 4. If that was a minus, remember we could factor it, would be a difference in squares. Okay, what can we do with this one? Factor x out, minus,
4x plus 4.
will let's factor,
Yes, because the difference is
2 and 2 add up to 4, right?
X minus 2, X minus 2.
Okay, so let's do that. X, 2 and 2, what about the sign? It's the sum, they're the same? I mean, -2, -2. Okay, so this actually isn't part of our, we've replaced that with this. Now, least common multiple, the most, x's,
X to the third.
x to the third is the most. You need x squared plus 4. And you need both of those. The most in a row is 2 of them, so you have to put both of them in there. All of that's going to be the least common multiple.
When is this supposed to apply?
Right here.
No, I meant like applied in life. Just wondering, not like a smart aleck question.
You probably have to have a job that you actually are like in Intel or at Los Alamos where you're actually an engineer type of thing.
Splitting atoms.
Engineer and building roads or.
In other words, you will never use this again.
Where do I use it? I use it in life because I teach it, otherwise I don't use this in life. But knowing it makes it when you take the other classes to become like engineers and things like that.
So they should like not even include this if you're not going to become an engineer.
I had to take classes that I don't use just to see how much farther it goes to appreciate simplicity of this. I had to take calculus 1, 2, and 3. I took differential equations, vector
It's like
analysis.
saying I spent all my money to see what it felt like.
Yeah, yeah. So anybody that has like a associate, you know, they put up with this. If they have a bachelor's, you know, they put up with 4. If they have a PhD, you know, they put up with even more of stuff that they may not use, but they've learned it. So they are very persistent, stick-to-it people. That's why when you have a degree, you make more money because they know you're dedicated enough to stick to something.
After they train you, after all your money.
Yeah, after all that, then we train you. Okay, do we have a common denominator here? Yeah. The common denominator is x plus y. So we can just add the tops, right? Just like when we had a common denominator with numbers, we just added the tops. Once we got that common denominator, we just did 25 plus 8, right?
No.
And we've simplified. I tried not to, but I got caught. So make sure you simplify, if there's a way to simplify it. So we have on the top, we have x minus 2y plus x plus 9y. That's not simple, is it? We need to combine like terms. X plus x is 2x. Negative 2y and a positive 9.
7y.
Positive 7y. And we have x plus y. Can we factor the top? It'd be nice if this had been a 2, then we could factor the 2 out, and we'd have x plus y. Then we could cancel something, but, bless you. Nothing factors, that's as simple as it gets. It only gets more complicated. Okay. That's
I'm
a
gonna
really,
ask you not to simplify it, because I was looking at the videos today, the lecture
if
videos.
it says don't simplify,
Yes.
like, this problem here says to multiply it and not simplify. All they did is just multiply the top and multiply the bottom and didn't cancel anything.
Oh, okay.
So if it actually gave you a problem like that, all you gotta do is write, those 2 things on top and these 2 things on bottom.
Okay, so you just multiply and don't cancel it.
Right, no canceling. Don't simplify means don't cancel. So if it says multiply that, those 2 go on top, those 2 go on bottom. I didn't think it would have gave problems like that, but it may have. Because in the paper homework it didn't. It skipped all of those. Okay, so let's do another one. Multiply and simplify. Okay, let's see. We're going to add and subtract fractions, right? We'll do one more add, and then we'll start doing some subtract, because that adds one more concept onto the fraction thing. Let's do 4xy over x squared minus y squared plus, oops, sorry, this is a minus, sorry guys, minus y over x plus y. Okay. We need a common denominator. To get a common denominator, we need to make sure everything's factored all the way. This is not factored. X, y, the difference of squares means you have a plus and minus. That's why we learned the LCM thing, to get a least common denominator. Our least common denominator is this. We need this in there once, and we need this in there once. That's the most. So the common denominator is x plus y, x minus y. Let's rewrite what we have on top before we had the common denominator. We had that. But, okay, this didn't change, so the top won't change. So this part's okay. This got multiplied, didn't it? It got multiplied by x minus y. So this has to get multiplied by x minus y. Okay. I'm going to write all this on top. This, if you'd like to FOIL it before we write it down here, we could do that. If you have room above it, if not, you can wait till you come down here. Here's x squared. Outside, not minus xy. Right? Inside, minus xy. You can't forget this stuff, you're using it. You had to learn it last chapter, you gotta use it.
Minus y squared.
Plus.
Plus y squared.
Right. Okay, so we have on top 4xy plus all of this. X squared, let's combine those two, is a negative 2xy, and then plus y squared. Over our common denominator. Plus anything combined on top, the xy's combined, but let's put these in descending order of x's or y's. Might as well do x's. X squared plus 2 plus 2xy plus y squared over our common denominator. Will the top factor? It will, huh? Because 1 of these, 1 times 1, 1 and 1 add up to 2. So we can factor the top. Bottom still, common denominator. This is x and x. This is y and y. How are we going to get a positive 2?
Plus and plus.
Plus and plus. What can we do with that?
Cancel.
Cancel one of the x plus y's. So our answer is x plus y over x minus y. Can we cancel an x?
Yes.
Just say no. No, you may not cancel an x and you may not cancel a y. I do not eat eggs, green eggs and ham. No, I do not. Sam, I am. Not with the cat, not with the rat, not with the bat, not with a mouse or a house. Okay, here we go. I'm trying to simplify it. Okay. We're doing Dr. Seuss. Alrighty then. Let's do another plus and then we'll do minus. Is that enough pluses? Yes? Enough pluses or you want one more plus, somebody? Okay, let's move on to subtraction. Okay, x minus 1 over 3x plus 15 minus x plus 3 over 5x plus 25. We need a common denominator. We need to factor both of these. What does this factor out to? 3, no high fives, just 3.
X plus 5.
Plus 5, yes. You got a 5 there. How about this one?
Balance.
High 5, yes.
5x plus 5.
Plus 5. Okay, least common multiple is the most. We got a 3 and a 5. The 3 and a 5 will be 15, won't it? You gotta have a 3 and a 5, and we have to have an x plus 5. We don't need it twice because 1 and 1 is enough. So that's our common denominator. Okay. To get our common denominator, what did we multiply this by?
5.
Times 5? So we need to multiply the top times 5. Okay, I'm not going to write down here yet. What did we do over here? What did we multiply this by to get?
3.
Just the 3. The whole thing times 3, I'm putting it in the front. Okay? If we go ahead and make this addition now, it'll keep us from losing our minus in there. If you just multiply this and try to remember it was subtracting both of these, that's going to be harder for you to do. What you need to do when it says subtraction, change it to adding the opposite and put that negative so you don't forget to multiply it through. Okay? Now when I bring it down here, oh, this is plus now. When I bring it down here, I'm going to have it distributed. Okay? You could do it in 2 steps if you want. You could write this and the next line down. You could distribute it if you like. Okay, 5x minus 5. Negative 3 times x, negative 3x, negative 3 times 3, negative 9. So all of this will be on top. instead of writing it all out, let's combine our like terms. Our x's are like terms. 5x minus 3x,
2x.
2x. Negative 5 and a negative 9. Negative 14. Over our common denominator. Is that as far as we can go? No, we can factor the top. 2 times x minus 7. Well, that didn't make anything factor, but it's going to want the answer factored. Because you need to see if it'll make anything cancel. So you're going to write it in factored form. Okay. And another subtraction. Okay, 3y over y squared minus 7y plus 10 minus 2y over y squared minus 8y plus 15. Lots of factoring, right? Okay, and for this, y and y, it adds up
2 and
to
5.
7. 2 and 5, we need a negative 7,
Minus.
both negative. Same side, same sum, means same side. Okay, these are both be the same side. We have y and y,
3 and 5.
they add up to 8, 3 and 5. Same sign. Bless you. So, our common denominator, the most of every, I'm not going to put the minus because we're going to turn, I guess I will. We're going to turn into plus eventually. Okay, we need a y minus 2. There's not 2 of them in a row, so that goes once. And I'll just do them in order. Y2 and then 3. And there's 1 here, 1 here. You only need 1. So it's y minus 2, y minus 3, and y minus 5. Common denominator. Let's write what we started with here. Oh, I should put it up here and brought it down as fact as whatever, huh? Okay, what did we multiply these two by to get our common denominator? We got the 2 and the 5, so we must have multiplied it by this, right? So multiply the top times y minus 3, right? Might as well leave that minus there. Okay, we have the 3 and 5. So we must have multiplied it by y minus 2, right? We got 3 and 5. So multiply the top times y minus 2. What are we going to do with this thing? Adding a negative. Change subtraction into addition. Now, I'm just going to write CD on the bottom, and when we get to the end, I'll write this is a common denominator. Let's distribute 3y times y, 3y squared. 3y times 3, 9y. Plus the negative 2y times y.
2y.
Negative 2y squared. Negative 2y times negative 2.
4.
Plus
4y.
4y. Combine like terms. Y squared, 3 minus 2,
1.
y, just 1 y squared. Then we have y's, negative 9, positive 4, -5. That's gonna factor, so I'm still gonna put CD there. Okay? This factors to y, y minus 5. Okay, so the common denominator, we can write it down here. I should have scooted this way over. Because I need to write 3 things down here. The x minus 2, y, because we love you. Y minus 3 and y minus 5.
Can we cancel those?
Yes, we may.
Y minus 5.
Right. Those cancel, my marker don't write, but they cancel. So what do we have left? A y on top, and
Minus 2, Y minus 3.
a minus 2 and a minus 3 on the bottom. I like when it cancels and simplifies. You're probably the only one that enjoys that, huh? Okay. Let's do it with 3 terms. And addition and subtraction and stuff. Since I enjoy this so much. Ooh, it's almost time. Okay, 1 over. X plus 1 minus x over x minus 2 plus x squared plus 2 over x squared minus x minus 2. This should factor, probably have these, let's see. 2 is 1 times 2, subtract to give you 1, yeah. Negative 1, negative 2 positive 1. This is our common denominator. So, with that as our common denominator, what did we multiply this by? X minus 2, right? Right? So that's going to come down like that. What did we multiply this by? X plus 1. I want to turn this into adding a negative there. So we would bring it down as negative x squared,
Plus 1.
nope,
Oh. Minus 1.
minus x. Negative x times 1. We didn't multiply this by anything, so we don't have to multiply the top. We can just bring it down. Okay? Combine like terms, x squared and a negative x squared go away, right? That's 0. X and negative x go away. Positive 2, negative 2. Go away. So we have 0 over. Is it okay to have 0 on top?
Yes.
Yeah, just not on bottom. Zero's on top, what's it equal to? 0. That really simplified. You want another one or no? I know it's time. 2 minutes now. Okay, no questions?